Sound is actually acoustical energy that is perceived. The acoustical energy itself is something that is transmitted through a medium as a product of some energy being imposed upon that medium. So if you tap, for example, on a piece of wood, you will hear the energy of that tapping transmitted into the air, but it also transmits into the wood. So the wood transmits acoustical energy as well as the air. Transmitting it a little differently. The air is a compressible material, so we get a compression wave that comes off of that, and we sense that through our ears as a pressure gradient or changes in pressures in the air. Now what happens in the wood, to a lesser degree because it is not as compressible as air is, you get particle motion, where you get actually a vibration that happens in the wood that shakes, and that transmits the acoustical energy. Now if you put your ear on the piece of wood, you can hear it. And I use this example quite often in terms of determining how effectively air or wood or other materials transmit acoustical energy. If you reach your hand out on your desktop and scratch with your finger, you'll hear it in the air, the scratching. But if you put your ear directly on that desktop, you'll hear very loud the scratching. So the coupling, or the efficiency through which acoustical energy transmits through wood, is more efficient than what it does, how it translates or transmits through air. And this is much the same story with water. Because water is not compressible per se, and it is more dense, it's 3,000 times more dense than air is, it transmits sound really efficiently. So this is a reason you can actually hear sounds 3,000 miles away in the ocean.